Hello and welcome to the first in a series of videos about the Pipeline Pilot Chemistry SDK, or PPChem SDK as we call it. This is a way of doing BIOVIA chemistry but without Pipeline Pilot. And what better way than to do chemistry in a Jupyter notebook making use of the Python API to the PPChem SDK. This is going to be a simple cookbook with lots of different things that you can make. In today's video, we're probably just going to boil an egg, but hopefully it'll be full of lots more spicier stuff as time goes on. So let's get going. The SDK comes as a wheel, so it's very easy to install into your Python environment, and we simply make use of it in the notebook by this import statement. So the first thing we want to do is get some chemistry into our notebook, and the workhorse class here is the mol.io class, and we're going to make use of this in several different ways. The first thing that we probably want to do is just simplest thing is to read a structure in from a smiles. So to do that, we create a helper object, the mol.io object, and we also create an empty molecule, chem.molecule. We supply the smile string, and then we simply pass those two objects into the read molecule method of mol.io, and it will populate the molecule for us. And now we can start calling methods on that molecule. So for example, the number of atoms is 15, which agrees with what you can see in the input smiles. Suppose instead of smiles we had a mol format or a CTAB or something like that. It makes more sense that would be a file on disk, but it's very easy with Python to open that file and grab the contents as a CTAB. And again, we call the read molecule object. Here we make sure to tell it that it is of type CTAB or SD. We've also given a meaningful chemical name to our object, and we'll have a look at that later, the structure. Okay, so if we can read a mol file, how do we read an SD file? Well, you can do that. It's going to take a little bit more work. What we need to do is make use of the Python infrastructure to iterate over the molecules in the SD file. And there are different levels of complexity of that. What we've got below is a generator. A generator is an extremely quick way of reading a molecule, reading a set of objects in. What it doesn't do, I won't talk through the detailed code. What it doesn't do is put them anywhere in a list, but that's very easily done by this syntax here. So we call the generator method, and then we simply use list comprehension, and then we end up with this list of molecules. The generator gives us as well the properties in the SD file, and then we can access those. So for example, I can say for the first molecule, get me the property called name, and it's alanine. Okay, so we're reading in molecules. How do we show them? Well, again, we have a couple of workhorse methods, calculate 2D coordinates and calculate picture. This one makes sure that we have reasonable coordinates, and this one actually generates the picture. So like we did with reading in a single structure, we'll calculate a couple of helper objects, set the image size, that sort of thing. And then a very simple wrapper structure function to actually call these methods on the molecule object and display it. And here to display, I'm using matplotlib, which is a very commonly used Python graphics package. And we can simply call our helper method plot structure, and there we see the structure. And it's not the world's best structure, but in a later Jupyter Notebook, I'll show you how to fix it. Jupyter Notebooks, or the IPython package, which sits behind Jupyter Notebooks, is absolutely amazing. It has this thing called rich outputs. So it allows us to provide our own representations of objects rather than the default ones. And so we can get it to simply represent structures, molecular structures for us. And we do that in two steps. The first thing is we have a helper method like we did before for plotting the picture, but instead here we simply calculate the bytes of a PNG image. And the second step is to tell Jupyter Notebook, hey, whenever someone wants to represent a chem.molecule object, please call my method. So with those in place, I can simply type the name of the object and Jupyter Notebook knows how to represent it. So that's syspride there. What about a grid of structures, so our SD file? Well, again, we can make some nice helper objects. I've got one here that will display a grid of images. So if I give it lots and lots of images, it will figure out rows and columns and so on and so forth, and then plot each in its own subplot. To generate the images, and I'm using the Python image library here, or Pillow, I have another helper method, and so to use this, I simply will iterate over the molecules in that list of molecules that I created, create the images, and then pass those images into my display helper method, and there we see a nice grid of structures. Okay, so we've done some basics here in the cookbook. We've read in structures and we've displayed them. Ultimately, as I said, we're going to have, I hope, some very spicy recipes in this cookbook. One of those, I believe, is organometallics, ferrocene, haptic bonds, and that sort of stuff. But I'm going to stop this video here. I'm going to take on this subject in a separate Jupyter notebook, and I hope that should be of interest as well. Thank you for your time.